Okay, this is Victor Landy, and this is Artifact 2, the category of data structures and algorithms. And I'm going to be using the lab assignment 4-2, also from the course CS260, Algorithms and Data Structures. Now, I chose this one because it gives a little variety as opposed to Artifact 1, where you could enter bit information and then display it. What this program is going to do is it's going to load bit information that's going to be coming out of CSV files. We have this one that does about 179, which would be a sample for the month of December of 2016. The one below does about 18,000. So it's giving it more to work with. Now what this one is going to do is it's going to either load the bids and then display them, or we have two sort methods, a selection sort and a quick sort. So let's talk about this one a little bit. Go through the line by line. I'll provide a demonstration of the program, do a code review, and then I'll tell you what my enhancement choice is going to be for this artifact. Now this C++ program deals with sorting and managing bit information loaded from a CSV file. It offers two sorting algorithms, selection sort and quick sort. And we have, as before, we include algorithm, IO stream, and this time we're going to add time.h. Now these are preprocessor directives that include necessary libraries for the various operations working with vectors, input-output, and measuring time. Okay, we're also going to include the VSP parser. This includes a custom header file for parsing CSV data. And it'll be used to load the bid data from the CSV file. And using the name standard, just as in the other program, this statement allows the program to use the standard namespace without needing to preface all standard library functions and objects with standard : Okay, now to structure the bid here, this defines a custom data structure named bid that holds bid information, including the bid ID, title, fund, and amount. That's what it's going to be retrieving when it loads the bid information. Now various functions are defined, including display bid, get bid, load bids, partition, quick sort, and select sort. Now the main function is the entry point of the program. It accepts command line arguments and processes user input through a menu system. There we go. Didn't catch up with my description with the display of the code. There's the menu options. Now the program processes command line arguments to determine the CSV value path to load. If no argument is provided, it defaults to the monthly sales, the larger one that has the almost 18,000. Okay, and a vector named bids is declared to store bid information read from the CSV file. This program enters a while loop that displays a menu, the menu, and waits for user input until the user chooses to exit. Inside the loop, the program displays a menu with options to load bids, display all bids, selection sort all bids, quick sort all bids, and exit. Now here we have choice. This line reads the user's choice from the console. Now the different cases, the program uses a switch statement to handle the user's choices. So case number 1 is going to load bid data from the CSV file into the bid vectors and measure the time it takes. It's going to do that and display it in seconds. Now case number 2 is going to display all loaded bid data. Choice in case number 3 sorts the bid data using the select sort algorithm and measures the time it takes. And case number 4 is going to sort the bid data using the quick sort algorithm and measure the time it takes. After processing the user's choice, the program repeats the loop until the user chooses to exit. And if they hit option 9 to exit, it's going to say goodbye. Now a selection sort is a simple comparison-based sorting algorithm. It repeatedly selects the minimum element from the unsorted portion of the array and swaps it with the first element in the unsorted portion. It has an average and worst case time complexity of 0, then n to the power times 2, making it inefficient for large data sets. It performs a constant number of swaps, making it suitable for situations where memory writes are costly. Now the quick sort is a more efficient comparison-based sorting algorithm. It divides the array into 2 sub-arrays, low and high, based on a pivot element. And then it's going to recursively sort the subarrays, making it a divide and conquer algorithm. On average, quicksort has a time complexity of 0 n log n, making it faster than select sort for large databases. In the worst case, it can degrade to 0 n to the power 2, but this is less likely to occur with good pivot selection strategies. Quicksort can be more memory intensive due to its recursive nature and additional function calls. So to summarize, the selection sort is simpler but less efficient for large data sets, while quicksort is more efficient on average but can be memory intensive and might have a worst case performance issue. So the choice between sorting algorithms depends on the specific requirements of the application and the size of the data set being sorted. So let's take a look at the program in action. So we run it, we get the menu options. Now if we choose option 1, we load the bids. And it did that fairly quickly. And it did almost 18,000 of them. Now if we want to display that, we're going to choose option 2. And it's going to display all of them. Notice we have this one last, the 98912, a Chevy Tahoe for $233.45. If we look at the bottom for our CSV file, we see that that is the last entry. So it's going to do that in ascending order. The number's going to get bigger as we go down, but this is the last one on here. So to go back to the program, let's do a selection sort. See how long that takes. I've been averaging around 8 seconds for this one. And we have 8.382 seconds. Okay, we're going to display the information. And this one's going to do it by the types. So you see those grouped together. Okay, now let's do the quick sort, aptly named, because it's really fast. And let's retrieve that. So that one does it a lot faster. Now, we want to exit the program, hit 9, and the program terminates. Okay, let's go over the code review. Let's take a look at the structure. Now the code appears to completely incorrectly implement the design, which involves loading and sorting bits. Generally conforms to C++ coding standards, including appropriate use of headers, functions, and variables. Code is well structured, consistent in style, and consistently formatted with appropriate indentation. There is no uncalled for or unreadable code. There are no leftover stubs or test routines in the code. Some code could potentially be replaced by calls to external reusable components or library functions, such as the sorting algorithms. There is some repeated code for sorting, the selection sort and quick sort, which could be potentially condensed into a single procedure or a template function. Storage use efficiency is acceptable for the data structure used, which would be vectors. Symbolic names are used instead of magic number constants or string constants. While the code is reasonably well structured, some functions could be split or refactored for improving clarity and maintainability. The code is reasonably documented with comments, explaining the purpose of functions, loops, and key operations. Comments are consistent with the code and follow a similar style throughout the code. Variables are properly defined with meaningful, consistent, and clear names. Assigned variables have proper type consistency or casting. There do not appear to be any redundant or unused variables. The code does not involve comparing floating point numbers for quality. There is no need to systematically prevent rounding errors because the code does not perform complex floating point arithmetic. The code does not involve additions or subtractions on numbers with greatly different magnitudes. Divisors are not tested for zero or noise in the code. The loops, branches, and logic constructs are complete, correct, and properly nested. Common cases are tested first in if, else if chains. All cases are covered in if, else if, or case blocks, including else clauses. Every case statement does not have a default since it's not applicable to this context. Loop termination conditions are mostly obvious and achievable. Indexes or subscripts are properly initiated before loops. Some statements within loops could potentially be placed outside for optimization. The code in the loop does not manipulate the index variable or use it upon exit from the loop. Indexes, pointers, and subscripts are not explicitly tested against bounds. Imported data and input arguments are not tested for validity and completeness in this code. Output variables are assigned appropriately in this code. The correct data is operated on in each statement. Memory allocation and deallocation are not explicitly managed because the code primarily uses standard C++ vectors, which handle memory management internally. Timeouts or error traps for external device accesses are not relevant in this code. Files are not explicitly checked for existence before attempting to access them, although the code does handle potential CSV parsing errors gracefully. The code does not leave files or devices in an incorrect state upon program termination. So to summarize, the code is generally well structured, conforms to C++ standards, and is adequately documented. However, there are opportunities for code improvement, especially in terms of code reuse and refactoring for better clarity. And defensive programming practices such as bounds checking could be added for increased robustness. Now, what I'd like to do for enhancements is, let me go back and start it again. Okay, notice what happens if I try and display all bids without loading all bids. It's going to bounce me back to the menu. And if I try and do a selection sort, it's going to take 0 seconds. And it's not going to show anything if I hit display because we didn't load any bids. Same with 4. So what I'm proposing for an enhancement, first enhancement, well, actually I'm getting ahead of myself, I'm sorry. My first enhancement is going to be a prompt. I want to personalize this code a little bit more, make it a little bit more user-friendly. So my first proposed enhancement, what I will do is have a prompt where it'll prompt you to enter your name. So once you enter your name, you hit enter. Now it'll prompt you to enter the year you were born. So you put that year in, hit enter. It's going to return that information and greet you. It's going to say, hello. Like in my case, it would be, hello, Victor. You are 62 years old because my birth year is 1961. So I am 62, or I will be in 18 days. But after that, it'll display the menu. So we'll have the name, the year of birth, the greeting, and then the menu options. Rather than just jumping into a loop of it not knowing what to do if you hit either option 2, 3, or 4 before option 1 to load the bids, it's going to give you a prompt. It's going to give a message, rather, that says, please load bids first if you choose 2, 3, or 4 before 1. Once you load the bids, then it'll continue like it does here. You hit 2, it'll display all bids. You hit 3, it'll do the selection sort, and 4, it'll do the quick sort. And if you do 9, it'll exit the program. The next enhancement I want to do is I want to work on the time it takes to do option 3, the selection sort. I'm averaging about 8 seconds right now. I want to work on using a different sort strategy, maybe bi-directional, something that's going to cut that time down so I have, it's going to take less time to do a selection sort. So those are the enhancements that I'm proposing for this artifact. And doing that, it's going to aid in demonstrating some of these objectives, like to design and evaluate computing solutions that solve a given problem using algorithmic principles and computer science practices and standards appropriate to its solution while managing the trade-offs involved in design choices. Working on cutting down the time and using a different sort strategy, making it more user-friendly. Those things, I believe, will demonstrate that. As with all the enhancements and the documentation, that lends itself towards aiding in the design, development, and delivering professional quality oral, written, and visual communications that'll be coherent, technically sound, and appropriately adapted to specific audiences and contexts. That's what I'm striving for Artifact 2. I thank you for your time and attention.